welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic Introduction to Chemistry, and we are going to be looking at the Bunsen burner. Today we are going to be looking at effects of heating different water particles, water solution with both luminous and non-luminous flame, and we are going to make some conclusions. Previously, we discussed on the luminous and non-luminous flame, and we looked at different regions of these flames and how they are both produced. And also we looked at the characteristics of this flame, and we also looked at some of the advantages and disadvantages of each and every flame. You can go and check the videos on the same and see what we discussed. So for today, we are going to look at the effect of heating with luminous and non-luminous flame, make some few conclusion, and then do some questions in regards to what you're going to discuss. So let's begin. So what happens is two beakers were picked and were added equal volumes of water in them, and then they were placed on a wire gauge that was placed on a tripod stand, and then they were heated with a luminous flame and an unluminous flame separately but at the same time. And then the temperatures were recorded using a thermometer, and also the time was kept. So after some time, the time was recorded as well, and also the temperature also was recorded. So one of the observations that was noticed in this experiment is that water that was heated over non-luminous flame boiled for a shorter time than if the same amount of water was heated on a luminous flame. So the non-luminous flame took a shorter time, and then luminous flame took a longer time. So that's one of the observations that was noted. And then the next observation is that on the bottom of the beaker heated with the non-luminous flame, it was very clear and clean, but at the bottom of the beaker is heated by luminous flame, there were some black deposits. So there was some black deposit on the bottom of the beaker that was heated by luminous flame, but the non-luminous flame, it was clean. So these two observations helps us to know that when these two flames, luminous and non-luminous flame, are used, always the non-luminous flame will be preferred because it's going to be hotter. That is the reason why when they are both heated, you notice the water that was heated by non-luminous flame boiled faster, or it took a shorter time to boil in comparison to luminous flame that took a longer time for it to boil. We also see that the hottest part of the luminous flame and also the hottest part of the non-luminous flame is also on the outer blue zone. And then in the incomplete combustion in the luminous flame leads to the production of the carbon particles. And we said because of the incomplete combustion in the luminous flame, these carbon particles usually glow when heated, and they glow in a yellow color. So when they glow, they're the ones that produce that yellow color we see in luminous flame. And when they cool, they are deposited on the bottom part of the beaker, and that is what we get the black soot from. As for the non-luminous flame, it undergoes a complete combustion. So this complete combustion means that the carbon is going to burn and also hydrogen is going to burn, because we said it's made up of laboratory gas, made up of hydrogen and carbon. So when this burns in air, what happens is the hydrogen burns in air to form water, while carbon burns in air to form carbon dioxide. So there's no soot that is being formed in the non-luminous flame. So that is the reason why the lower part of the beaker is very clean. So this makes us to make a few conclusions in regards to these two flames. First of all, the non-luminous flame is hotter than the luminous flame, and the non-luminous flame is cleaner than the luminous flame. These are the two main reasons why we prefer to use non-luminous flame in the laboratory over luminous flame. So that brings us to the questions for the day in regards to what we have discussed. So you have been told the first question is give two reasons why luminous flame is not preferred for heating purposes in the lab. So we do not prefer the luminous flame because first it produces soot. This soot dirtifies the apparatus. Number two, it does not produce a lot of heat. And we know why it does not produce a lot of heat is because it does not burn completely. The laboratory gas does not burn completely because there's no sufficient air getting into the chimney. Then the next question is equal volumes of water put in 100 centimeters cube a glass beaker and heated for 5 minutes using Bunsen burner flames. It was observed that the water in beaker A registered a higher temperature than beaker B. So we have these two beakers, beaker A and also beaker B. So beaker A registered higher. This had a higher temperature than beaker B. So this question is name what kind of flame used in beaker A. The moment we see that beaker A had a higher temperature or burnt faster, it means we were using non-luminous flame. So we used the non-luminous flame in beaker A and beaker B, we are going to be using luminous flame. State the condition under which the flame that heated B was produced. So we are being asked under which condition the luminous flame is being produced. It is produced when the air hole is closed. So that's when it's usually produced, when the air hole is closed. So that concludes the questions and also on the discussion we have been having on non-luminous flame. So don't forget that in the lab we prefer non-luminous flame because it's hot and doesn't produce soot. And we do not prefer luminous flame because it's not that hot and it produces soot. So in the next lesson, we are going to be seeing the hottest region in the non-luminous flame. Since we are preferring it, we are going to study it more. So see you in the next lesson.